Awesome.
Okay.
Perfect. All right. So can you guys see my screen?
Yeah.
Yeah, all good.
Okay. So we all know what these scans look like. They're sometimes quite messy. We've got is it a Shining 3D scanner? I don't know what you guys use, but it's quite a good scanner actually. But we know that all of these have been like separated and the dies are all individual and so on. So the first thing that we always check is that it's like sort of in the center of Blender as we always drill in, it's got to be in the center of Blender. And then we're going to do this bridge this morning. So, all right, so in the crown module, then as we've always discussed, we're putting these into certain collections. So Wolf, maybe you want to comment, so that would
Yeah,
make things a
so
bit easier.
Michael's going to select the dies, and everything related to the working will go into a working collection, and antagonist into the antagonist. So Blender knows exactly what is what. And of course, by aligning it in the center, Blender is being told, what is vertical and what is all the directional coordinates. Excellent.
Okay, so let's get a few teeth. But I'm going to go into the components module to get a different tooth library.
So if you don't have a tooth library, you can just import, you can source one and then import it through the file, import STL or OBJ. The components module, the file format is all OBJ. That's just how the thumbnail images link to the actual digital files. Okay, so just placing it, Michael, selecting the teeth you want.
Proszę mnie informować. Natomiast kontaktują się moi adwokaci. Pójdziesz do domu.
Okay, so just using certain keys, the G key to pull it down, R key to rotate the tooth library, and then scaling it if needed.
So sometimes a tricky bit is the spacing. And of course, in a different situation, these teeth are over creative. You can see the anatomy. We'd probably not use a tooth library like this, but I just wanted to demonstrate because, once the teeth have been cut down and whatever, we do lose a little bit of tooth texture and anatomy. So it is sometimes a little bit tricky in deciding how we're going to be placing these teeth, because as you can see, the tooth prep is there, and then we've got another. So sometimes the spacing is quite hard. So in this instance, what I've done is I've changed this, and I've used 3 premolars. Now, yeah, so in my example, so I've actually scaled it down somewhat, and now actually the fit, the fit is really good like this. So anyway, we move the teeth as we usually do, and we delete what we don't want to do. So that takes a little bit of time. So I'm going to skip straight to the next file because we just want to save on time and make this a little bit more efficient.
So we
Okay,
use
so
solid tooth libraries for this one. If you want to add pink gum around it, then you would have one open tooth or so on, but generally closed tooth libraries.
yeah, closed tooth library. So I have used one extra premolar here. I just find the spacing of a molar in between, or it wasn't quite right. So I've actually used 3 premolars in this one. So it's up to you how you actually do this. So once we've got that, we need to remesh these teeth, and this is so that we can get a consistent mesh structure. Every tooth library you purchase or you make yourself is, it's different. So we're looking for consistency. And when we put this into the collection, it actually does, it remeshes it, but it hides it at the same time so that we can then draw our margins. So if you look at it, the consistency is something like that. And we depend on the interspace between the vertices for the module to actually work correctly. All right, so we're going to just hide that. And then we're going to engage in actually marking our margins. So this takes a little bit of practice. It's not too difficult. We select the die and then we start drawing it.
So each stage is kind of color coded. This part of the scan turns green, which is, we call it segmentation model, and specific for outlining the margins. And we're really only focusing on that particular die. This will create a green surface for lower teeth, and in the upper jaw, it'll create a yellow surface. Now the surface will become part of the inner fitting surface of the crown, but there's a couple of other things we need to add. We have to block it out, the die, put in a cement spacer. So there's various factors.
So what we're going to do with the pontic area, we're going to do the same thing. But sometimes we can see that the scan is a little bit far away from the actual tooth prep. And in that case, what I would suggest is we're going to pull this across a little bit so that when we actually do our cut, we're actually getting the pontic space a little bit closer to the actual die. So you've got to be careful how you're doing this, but I'm just stretching it across a little bit. Okay, and then what we're going to do is we're going to do exactly the same thing, and we're going to place our cursor and we're going to start drawing. You can manipulate the gum by sculpting it or, smoothing it down or whatever you want to do as well. So, okay, here what we're going to do is we're going to do the same thing. We're going to outline, and this becomes a cutting object at the end of it.
So actually outlining it a little bit larger than what you need to, so that you're sure that the pontic tooth touching surfaces will lie within that boundary.
Yeah, so when I look at the teeth, I want to make sure that this cutting tool is actually correct. Okay. So, and then what we're going to do is we're going to apply this, we're going to create the lower surface. So, okay, so I'm going to just skip this, and we're going to do that then for the actual, this die as well, and then we're going to outline the contact area. Well, maybe you can explain that with the contact area.
Yeah, so contact points are extremely important with crown and bridge work. And we are focused on that because we want to block these contact points out as well. And yeah, so Michael's just going to outline it at a 45-degree angle. So we're creating a little model out of this in the background.
So now that we've got them all done, we've got all of the elements that we need to do a bridge. We've got the saddle area, we've got the preps, and we've got our die. The next thing we're going to do is we're going to engage in the actual surveying. So the menu follows quite a logical order. So we've just finished drawing surfaces. We've got something with drill compensation, which we can add in as well. I'll just add something in to demonstrate how that works. So if the drill is like 1 millimeter, we can put 1.1, maybe a little bit bigger. We select our surface and we expose the thin areas. Then like here, for example, we may want to block out a little bit. So we can quite easily do that. So we're going to block that area out. This one we're going to leave. So we're painting on the surface, and then we're going to block it out. And that creates a very small object like that. It's a bit like, you know, in a lab we would take a bit of wax or like a filler to make sure that that hole is blocked out. Okay, and then we're going to accept that, and that will make a little red blob like that. And that will then be a void on the inside. And we can do the same thing wherever you see like a really sharp area. After that, we're going to take these and we're going to survey. So this hides everything else, puts it in the middle of the screen, and then we get to go inside this, and then we need to ascertain the best path of direction. I'm looking specifically here and over here. So this takes a little bit of practice, but we've been doing this all along in the lab anyway, so we sort of know how to do this. And then we block out the lower. So this takes a bit of time to calculate because it makes the dies underneath the blocked out dies. It creates quite a few objects behind the scene. All right, so with that being done, we can now get to separate what we need. So this is the contact. We want to eliminate that out of all of the calculations. So I'm going to click on the lower contact, which then makes that into like a pink surface. Then what we're going to do is we're going to take this one and that one, and we're going to put support margins on there. So these are just to prevent chipping. So you got a choice of 50 microns, 100 or 200 microns, but you can create your own margins as well. So I'm just going to click on add 0.2 millimeters. So as you can see, it's actually created a white little line around it like this. Okay. And then
So
following that,
this is actually a good checkpoint. This support margin is critically important to connect onto the tooth library. So if you just do a quick inspection to make sure it is not folded over or in a different direction. If it is, then you can, like Michael said, you can just make a new one. It's very easy to do.
yeah. So the shading has changed a little bit. It's inside out. So if the normals have been flipped, but at this stage it doesn't really matter. So this is exactly like it should be. And then what we're going to do is we're going to create our spacer and our zone around it. So we've got an auto space and zone which does it automatically, but just for this live webinar, I'm going to just make it so you guys can see how this works. So I've selected my blue abutment with margin, it's called, and we're going to add a spacer. Now this spacer is by default, it's 50 microns thick. It says 0.1, but that's because it's 50 inside and 50 outside. So this is critical. So we've actually got it, it says ×2. So if you wanted 100 micron, then you just put this at 0.2 millimeters, which will actually expand it outwards and make it thicker. So we've got a nice coverage. Also note that this blocked out little piece that we've blocked out like this over here has then been covered with the die space. It's invisible at the moment, but this is exactly how it needs to be. Then what we're going to do is we're going to decide how far we want the spacer from the margin. This is called the margin distance. The default, we've got it set at 1 millimeters, but if you want it smaller, closer to the margin, you can always creep that towards a margin. So if I use a slider, you can sort of see what happens here. So we can, and then we can, we've been asked if we can make an inverse. So we've actually created an inverse as well. It's probably for dentine bonding or
Enamel.
so on. So enamel bonding. So let's just set that back to default values, and we're going to accept that spacer. And again, this one does it automatically with our default values. We're going to then add a safety zone, and this safety zone is a representation of how thick the crown is. So we can actually understand the default is 0.5, and when we accept that, it makes a layer. So this is indicative only. Okay. So I'm going to open up a new file. We've actually done the other one as well. So this is sort of the mid section of the actual procedure. So if you guys have any questions, would be quite good just to engage in that.
Yeah, so here it would divert into making copings or full contour. So it's most procedures follow the same process up to this point. Andrew, you had a question.
Yeah, hi guys. You place quite a lot of importance on the color, as in the blue and the pink for the contacts. And just due to my playing around with different themes on Blender and putting different things on, obviously the colors have all changed. I rolled it back to the previous theme that you guys suggest when you actually install Blender for the first time. But again, the colors have changed. They're not correct. Now, for me, it's not a major problem because I know what the colors are and I know it's working fine because I'm used to it. But for new people, where do those colors come from? Are they automatically with the model module when you install it from scratch?
Yes, Andrew, they are. They should always be the same color. Whenever you use it, it should be the same color, unless you've got it changed in your settings. If you have a look in the matcap, you have something called random, and that'll change the colors. So I don't know, maybe you can check that this is on texture, because the color theme should always be the same. And this is simply because then we can help people along the way, because if we get a request, my contact or whatever, there's something wrong, we can say, has it turned this color? Or, you know, so it's, for us, it's easier to help the users along the way.
Yeah, I can actually see the logic behind your reasoning on that. And I just wondered if it gets mixed up, where do we sort of go back to default and we can restore what you guys have sort of put in there? But if you say it's on the settings and it's in, I think, sorry, go back to that again. You went to, it was texture, wasn't it? That's it.
It's random.
It's random.
If it's set,
Okay.
if it's set to random, it'll change. But in the texture, it should always be the same.
Okay. All right. Yeah, that's super. Thanks, guys.
Excellent. All right. So now we're going to focus on the occlusal adjustments. And so we're going to expose the antagonist. And this is where we're going to create a cutting object. So Wolf, I'm just going to do this, and perhaps you can just comment on how we're going to do
so
things.
the antagonist, like Michael said, we're turning that into an object. At the moment, it's just the scan mesh. So he's kind of solidifying that part. But in addition to that, we're going to offset it. So it's making a duplicate cutting tool behind the scene, which you can then expand outwards. And the reason, and Michael's just done that, you can, by default, we have it set to 0.2 or 0.1. In our experience, we use 0.2. This is so that you can, if your zirconia crowns or Emax crowns are continuously high in bite, you just need to change that offset. So making that model that cutting tool a little bit bigger will do the trick. Now Michael's going to go into a live cutting process where you can set the crowns individually into the vertical height. So now we've got to work out a compromise between setting the crown too high vertically, which means you're essentially cutting off your occlusion. As you can see, as Michael's lifting the tooth, it is cutting it with the invisible antagonist. So if you set it too low, we're getting a crown that's going to become too thin. This is why the green safety zone is indicative only. And the goal here is to then pull the mesh over the green safety zone, which he'll do in a minute. So you can use this live cutting tool on each tooth individually. You can also join them and do it all in one go. But because it is probably best to do it individually. So getting that ideal vertical position of the tooth. Okay, so the next process would be to cover those little green specks. And Michael's using the inflate and deflate button. The tooth turns color, and he's just brushed over that lightly, which will inflate that green spot. So likewise, are you doing it on the other one as well, Michael? No, it's all good.
No, I'm going to engage in the Pontex now. So we'll go to the Pontex menu.
Okay.
Okay, we're selecting our Pontex, and we're going to then click on that, and it'll say Pontex there. Then what we're going to do is we're going to cut these Pontex. So here, if you wanted to change the Pontex, and you think, okay, you know, maybe it's too much of a ridge lap or something, you can always take this and manipulate the mesh where you want the Pontex to be. Okay. Then what we're going to do is we're going to cut the Pontex. So this is where the outline has actually come in so that we can actually do this. Now, the underneath side of the Pontex, we can see we've got this feature where you can have a bit of a tissue compression. And so all we need to do is we need to click on this arrow, and every time we do that, it will compress it by 0.1 microns, 100 micron compression. So this is up to you if you want to use this feature or not. Let's try and do it with this one, and it'll bring it out by 0.1 tissue compression. Okay. So of course you can change these Pontex as well later. You can smooth them down. You can do whatever you want with them. All right. So the Pontex have been designed. We're going to go and do the crown generation.
So here, working in edit mode, the goal is to pull the mesh over the pencil line, and that will give it a better tooth emergent profile. And because the proportional editing function is on, you can see the little icon up top. You can then easily pull that out. And notice how the magnet tool is also active on the upper part of the toolbar. This means the mesh will kind of want to stick to any underlying surfaces. So just pressing that generate lower crown button, and that will perform all those necessary calculations. It will create the inner fitting surface, subtract the block out model, subtract the cement spacer, and connect the support margin onto the tooth library. So just inspecting the mesh, you can actually see on the inner side, fitting side, you can see the cement spacer. And if he had, I think on the molar, he incorporated that drill compensation block out bubble. So you would see it on the molar. So the quality of the mesh is pretty okay.
All right, so here I've generated both of these just to save some time. So it bulges out a little bit, but we can smooth that down. So that's not a real issue at all. The next thing we need to do is we need to think about how we're going to connect all of these units up. And that's quite easy because we're going to go into the bridging of this whole thing. And the first thing that I want to do is I'm going to do a union of these. So I'm going to select all of those and click unify these. Okay, so and that will then join the contacts up. But it's very important to have an intersection for them to join up, because if they are standing apart, it's not going to you know, so the mesh actually looks like this, and in transparent mode, I can actually see there's a hole in this one where the contacts are. This means that they are joined up correctly. And then what we're going to do is we're going to strengthen the structure a little bit. So by doing that, we're going to click on this one, and this will actually make a like a protection tissue model underneath it. So if you're making, and this is very important, because when we're creating these blobs to strengthen this bridge, we want to make sure that if it goes into the fitting surface, that it's not going to actually hinder or harm our fitting surface. So here what I'm going to do is we call this welding. So I'm going to click on weld, and this brings up, it's like a blob of wax. Okay, so by clicking Shift D, I can then duplicate this block of wax and then add as I want to go. I can scale this as well, just by using the usual Blender keys. S to scale, Shift D. So very important that you guys get familiar with these Blender shortcut keys, because it's going to help you along the way. Okay,
And
so
also working with a magnet tool is quite important here.
Yeah, working. Sometimes you want to work with the magnet tool, other times you don't, because if I want to move this inwards, I can then disable the magnet tool and use a G key just to bring that in a little bit more. So we can hide all of this. We've got a button here where we can actually decide what we want to hide. So here I can say, for example, I can say, okay, this model I don't want to see, or the lower segment I don't want to see. So we've got very good control over what we are actually doing. So here we can, I'll go Shift D again. Notice how it blobs on the inside. We don't have to worry about that at all. So again, put the magnet tool on, and here we can just design our context. The reason why we've actually decided to go with these blob things like wax is so that we can then in the future attach like chrome cobalts or something by merely drawing this down onto the actual model.
Or precision attachments.
Yeah, for precision attachments. Then what we're going to do is we're going to join this weld. Okay, so that unifies the entire thing, and then we can smooth this down. Okay.
Now this is a protection layer. The gray color is indicative of that. So yeah, it's not going to affect the fitting surfaces at all.
So here I'll just give it a quick smooth. So if you guys are worried about strength and you wanted to measure the contacts, we can do that as well. And you can always add more if you want to with that welding tool. It's quite easy to do. Okay, so I'm just going to smooth it down a little bit like that. All right, so from here, we're going to exit. And then finally, we want to do the contact. This is very important. We'll unhide everything else. And we're going to go into the contacts over here. So for you guys that don't know how to fold these into each other, simply click on Control left click, and that will then you'll only see the menu that you need to work on. Okay, so we're going to expose the contact. I'm going to select it. Now we can choose, if your contacts are always tight, we can engage in this manual way of doing this. If you're happy with the contacts, click on Auto Contact Cutter. For this webinar, I'm just going to do it the manual way, just to explain what's happened. So this has taken it from our path of insertion right at the beginning when we surveyed the model. Then this is offset at 50 micron. We can change it. So if you wanted 100 micron, we can change that. So as we're clicking here, this actually grows outwards. And this is going to be our cutting tool, okay? So let's just put it back to 50 microns, and we're going to apply that. Now then we're going to select our bridge, and we're going to go shape contact. Now, this will separate out everything so we can use this specific contact to bulge it out and smooth it. Okay, this is a bit like looking through a glass window, like a smoky glass window. And as I'm moving my tool, my inflate tool, it'll actually move through it. It's pulling it. It's pulling the mesh. And we can also deflate if we want to. Okay, so that means it's pushing it. When we're happy with the outline of the contact, we can cut the contact. So it'll actually use this as a cutting tool and cut it, as you can see. Now, we don't want it to be a concave contact. We can then smooth it. Again, the protection is on, which means that the dark layer is on, so we don't hinder or harm our fitting surface. And exit. And then finally, we can do a final smoothing if we want to, and then we're ready for export.
You can smooth the contact areas for the pontics as well, the underside, but you'd have to remove the masking tool. So you've got to be very cautious when you do that.
Okay, so export finish restoration, it puts it into a separate collection, and it also moves it to the middle of Blender workspace. This is so that it actually puts a point of origin into the center. If we would export the bridge the way it is, it will interfere with the positioning inside the CAD/CAM programs. Then what we want to do is we want to twist this over face upwards like that, and then we're going to export it. Click the selection only, type in whatever you want to name it, and export, and it's finished. Okay, yeah, Wolfgang, you're quite right with it's a bit sharp. We could have rounded that off as well. Okay, so I think that sort of completes it. So if there's any questions,
we can just
it'd be good
open
to
the
hear
floor
from
for
you.
questions. Well done, Michael.
Yeah.
What's the reason why you flip it over when you export it? Is that just for ease of use when you want to put it on a printer or milling machine?
Yes, it's a CAD/CAM software, so it's easier to have it face upwards, so the inside is face upwards.
Okay, thanks.
I would ask, where is that button to disable the mask protection in order to smooth out the pontics?
All right, okay. Let's put this to a test. Okay, so I'm going to look for a button here, generate crowns, smooth with crown protection. Okay, we're going to hide the lower one. All right, so you're going to mask, and then it says clear mask. Okay, mask is cleared, and we can start smoothing it down. Now, the reason why we haven't put this into our menu is because we don't want users to make a drastic mistake and then the fitting surface has been hindered. So this is up to you to be very careful and making very sure that you don't go extend to that side over here. Okay, like that. And then exit. And that's all you need to do. You can smooth it down as you like to. Excellent. All right. So I stop sharing my screen.
Was there a question about exporting, I think, to match the milling? I'm not so sure.
I see Daniel is here as well. Hey, we've got a lot of history.
He only joined like 2 minutes ago.
Oh, that's no good, hey, Daniel? Anyway.
Yeah.
Awesome. Thank you guys for joining. For us, it's coffee time. I hope you enjoyed it. If there's any questions, please
Atanas.
ask us.
Atanas. Yeah.
Hi guys,
Hi.
long time no see. I have a question. You said at the beginning, probably 20 minutes ago, that the tooth library is no good and so on. So it's not the perfect for the case. Can you show sometimes how you can mimic the other side of the jaw, for example, to copy the patient's teeth and so on and so on? In some future webinar, probably, as you did in WhatsApp, probably 6 months ago.
Yeah, so I think in the next video presentation, maybe we can cover that. Copy a front central incisor or bridge to the other side. We would typically cut it out. We would cut the mesh out so that you've actually got, you know, a bridge or a tooth or whatever. And then you will then just remesh it by putting it into the collection to get a suitable mesh, and then you will use that specific tooth for a crown or bridge. So it's exactly the same thing. We're doing exactly the same.
Like
you
in
may,
the WhatsApp model.
Yeah, with the wax up module, you may need to stretch that mesh down a little bit, because as we know, when we're cutting off a tooth, it may only be like on the surface, and you know we want to sink it down into the tooth prep. So with proportional editing, just pull that down a little bit and you'd be okay.
Nice, thanks.
Yeah.
So we had a question about adding precision attachments. So I think, Michael, you might want to do a bit of a video there. We've got good news. I don't know if you guys know Rhine attachments. It's a little ball attachment. So we'll be including that. I've used that many times. So I'm really happy to announce the Rhine attachments are coming.
The whole library of Rhine 83.
Yeah.
Wow.
Yeah. So that's coming soon. There's a few things we still need to do. We need to put the point of origin. I want to design a cutting tool to actually get rid of the inside when you're attaching a chrome carbide to it. But yeah, it's looking good.
And looking forward for the ortho model.
Yeah.
Yeah.
The orthodontic. Yeah.
Rhine is coming in a component model.
Yes.
Great, great. Great news. Great news.
Excellent.
Okay, so who come to the IDS? Because I will be there Thursday night, Friday, and Saturday. So I think that I think the John, okay, we have exchanged name. So
I wish I could go.
I think it will be a nice time.
Yeah.
I have some special emojis for that. Yes. Okay. So so for the free beers, and also I've made some nice card for Blenderfordental, and I think I will do some t-shirts also. So if you meet me, I will give you one. So that's the present. So come to the IDS. You have to be fully vaccinated. You have to have a lot of papers, but I think we will be 3 or 4 there, but it will be nice.
I think I'll see you then.
Okay. And by the way, for the French users, I have begun the translation of the Cronenbridge manual, and after we'll begin the video also. But for the moment, I'm just doing the first draft, so you have to be patient.
Wow.
Quite a lot of work at the office for the moment, but thank you for this presentation. I really like the way you handle the bridge. I think it's a good idea. I think we should also have a lot of more of teeth libraries in the shop. I think we lack some. So
yeah, what was the tooth library that you used in this particular case? What is the name of this?
It's a SUK library, S-U-K.
SUK.
Yeah, it's a very, very detailed, and it's quite a nice library. So if you want a lot of anatomy, then that's a nice one to use. Yeah.
perhaps we should do some compilation of teeth libraries. So the users, they buy like 10 to 15 teeth libraries, because when you're in the shop, it's quite hard to choose which one you want. I always want to buy all of them or nothing, and it finished by nothing. So I think that's a good idea.
Is that what happens when you go clothes shopping, like I do? I think I'm going to go clothes shopping, and I come home with nothing.
Nothing. Exactly.
Too many decisions.
Yeah, too much. I cannot choose.
Leave it for the woman to clothe you.
I don't want to leave my wife choosing tooth libraries. Goodness me.
So probably in the near future, you could add some part of the tutorials how to create tooth library, or in some webinar.
Yeah, but
from existing ones.
We can do one session of Blender instructors if you want, and you can show by step. I've done in a week. I've done my teeth, on my both my children's teeth with this technique. So it's quite easy to do. And as we have a lot of iOS scan now, we can really do a huge library.
It's something about 2 hours of work or nothing more.
Yes,
about picking a library.
2 hours, yes, I think.
Yeah.
Couple hours, maybe.
Baptiste, I heard you're using your tooth library for every patient, so all of your patients will be walking out with your teeth.
It's because I'm quite. I sign my patients with my own teeth.
Signature.
That sounds good. 2 sets of teeth, and if they fit, they fit.
Yeah.
Some very ecological dentistry. You see with Dr. Tyson, you have these teeth. That's a way of making my patient very happy. But I will show you some of my work with this test library. I don't have any time for the moment, but I think we can arrange this. So thank you very much, and see you soon, guys.
Yeah.
Okay. Thank you, guys.
Thank you.
Thank you.
See ya, guys.
Bye.
Thanks for
Thanks for your time.
joining. Okay. Bye, guys.
Bye.